Greetings, statistics students. This is chapter number 10, and we are going to work through problem number 3 on our homework. And problem number 3 corresponds to chapter 10, section 2, question number 6 from its homework. So we are told that the type of household for the U.S. population in a random sample of 411 households from some community in Montana are shown below. So there are these 5 categories. So married with children, married no children, single parent, one person, and other. So in the entire United States, 26% are married with children. In the entire United States, 29% are married, no children, and so forth. Then we took 411 observations from this community in Montana. And of the 411 observations, 108 of those were married with no children. And 97 of those were married with no children. So 108 married with children, 97 married no children. So if I look at just the second line, let's say, I take 97 divided by 411 observations, that's 24%. 24% is certainly different than 29%. So what we're doing is we are comparing all the United States households with the observations just from this town in Montana. If I add up all of these, I'll get 411. And then the question is the percentages of what was observed, is that statistically different from what was expected? And that's what we're trying to do. So this was observed in Montana, and this is what we expected in Montana, but they're different. And the idea is, are they statistically different? Okay, so let's actually work through this problem part A. What's the level of significance? Well, this says use a 5% level of significance, so that is 0.05. And state the null and alternative hypothesis. Well, remember, your null hypothesis is always a quality, so HO is always a quality. So different, no, is so they're the same, or are they same? And then your H1 is that they're different, so it's this one. The distributions are the same as HO, and the distributions are different would be your alternative. So then we have to find the value of the chi-stairs statistic. So how do we do that? Well, what we're going to do is put our observed in L1 of our calculator, and then we're going to put our expected in L2 of our calculator. So let's pull up the calculator here. So I go to my stats menu and edit. And I put the observed in L1, 108, 97, 36, 99, and 71. Once again, I got those numbers from here. Then there is my expected. That's these numbers. And how did I get that? Well, the 106.86 was I took 411 observations, and out of the 411, I expected that 26% would be married with children. So I took 411 and multiplied it by 0.26, and that's how I got this 106. And I did that for all of these categories. So then I quit and I go to my test. So I go to statistics and over to test, and I scroll down to the chi-squared goodness of fit test, and I hit enter, and I put the observed in L1, and I put my expected in L2, and then it asks me for my degrees of freedom. So where did the degrees of freedom come from? Well, for a chi-squared, it's k minus 1, where k is the number of categories, and there's 5 categories. So 5 minus 1 is 4 degrees of freedom. And I type in 4. And then I go down to calculate. And I get this number. So I put 19.019 for this one. 19.019 to 3 decimal places. And once again, that's this to 3 decimal places, 19.019. And then are all the expected frequencies greater than 5? So when I looked at my list, are all the expected frequencies greater than 5? So all of these numbers in L2 are greater than 5, so the answer is yes. And what sampling distribution will we use? And we're going to use the chi-squared. We've already done it, but sort of asking us in a funny order. The degrees of freedom are 4. And find or estimate the p-value. So when we ran our test, it told us that. And we're going to run it again to goodness of fit. And down to calculate. And it tells me this p-value. Now remember what this is. This is e to the negative 4th. So this would be 0.00793, right? That's what this e to the negative 4 means. I moved the decimal place over 4 places. So 3 decimal places would be 0.000. Now remember, your question may have slightly different numbers. So this may not be 0, and this number may be different. Remember that for your... So my p-value is small, and if my p-value is small as I reject it, so it's smaller than 0.05 for sure. So it's smaller than, so p-value is less than alpha. We reject. So p-value is small, we reject. And we're supposed to interpret my conclusion. So at the 5% level, there's evidence is sufficient to conclude that the community household distribution does not fit the general U.S. household distribution. So does not fit. H1 is that they're different, right? And then I'm going to submit my answer and see how I did. Looks like I did great. Okay, if you have any questions, let me know.